And welcome in, my party people. Welcome into our mixed arithmetic reasoning review. So, in today's class, everybody, aside from the traditional classes that we run, today we're going to be running a mixed review class where I'm not going to tell you what topics we're doing or how hard the question might be that you're going to be faced with. Today, it's going to be about practicing how we play. So, for those of us out here who may feel any sort of test anxiety whatsoever, this is going to be a great class for you. Because remember, I'm not here today presenting these problems to judge you. I'm not grading you. It's simply to see where you stand and the adjustments that you need to make to get better. And what better environment to do that in than in one that you're not going to be penalized for? Getting a question wrong today doesn't mean anything negative. It's only a lot of doors opening towards positivity. Getting what you need to know, understanding the nuances, and then making adjustments during your next study session. So even if this is your first time in my class, it's still going to be a great time because you'll be able to understand what topics you really want to focus on once you get into arithmetic reasoning. So with that said, my party people, here's what we're doing today. Again, trying time practice. We're going to get 2.5 minutes per question with a couple of seconds for buffer. And then from there, we'll reveal the concept and difficulty after each problem. So with that, let me go ahead and turn our attention over immediately to the list of topics that you can expect on the ASVAB Arithmetic Reasoning. So if you want to take a screenshot of this, I would absolutely encourage it. But we have at least one problem from each of these units, from general word problems to proportions, to unit conversions, percentages like taxes, discounts, simple and compound interest, distance, rate, and time, linear equations, systems of equations, area and perimeter, circles. About half of us are trying to puke right now. I understand, you're good. Volume and surface area word problems, other geometry word problems, statistics and probability, and advanced word problems. So again, hopefully I didn't just trigger anybody PTSD, but again, take it nice and slow. You can only do one problem at a time. So simply do your best. And whatever your best looks like, remember that we can always work to make it better. So with that, I'm not even going to joke. I'm not even going to say that today's all about torture and then, pretend I didn't say it. I really do want y'all to take today seriously in the sense of, hey, let's learn what I know and let's learn what I don't know. So again, like I said, everybody, we're going to get 2.5 minutes per question. All right. 2.5 minutes per question. And so if you're watching this as a recording, feel free to pause it at any point to try the problems out. But without further ado, we're going to get started pretty much right now. And let's give this problem a shot, my party people. So in this problem here, before we get started, I want to get your opinion. Number one, in terms of the difficulty of this question, would y'all say it's easy, medium, or hard for you personally? Yeah, for the majority of us saying that, yeah, this feels pretty standard, pretty easy, on the easier side. Yeah, I'll agree with you. This one's definitely on the easier side, but I want to go ahead. Let me just mark this as a 1. But I also want to ask the question, everybody, is there a chance that we'll get 1 or 2 or 3 or 4 easy questions on the ASVAB? Absolutely. Absolutely. We are going to get a small subset of easy questions. So we want to make sure that the easy questions look and feel easy, so that way we can crush them here and save time for those harder questions. So let's get it going here, everybody. Number 1, we want to start off with the question. Let's read the question here. And it says, what is the total number of stickers he now has? Everybody, before I continue, can we agree that really what we're looking for here is the number of stickers at the end? Yeah, just trying to find out how many stickers this person has. So stickers equals blank. We'll figure that out. Now, before you do any actual math, the best thing to do is understand the kind of math that we think we should be doing. So really what that means is, after we understand the goal, get your information, read your information, understand your information. A student bought 2 packs of stickers, each containing 10 stickers, and he already had 3 stickers before the purchase. So to me, what that says is, hey, we have 2 packs of stickers. Let me highlight that in blue. 2 packs of stickers. So we have 1 pack here, 1 pack there. Everybody, how many stickers are contained in each pack? Correct, we had 10. We had 10 in each, so it's basically 2 times 10. And then it says right over here that he already had 3 stickers before the purchase. So everybody, are we adding that 3 to the 10 before we multiply? Or are we adding that 3 at the end? Correct. We're going to be adding that at the end. Because again, it says he already had 3 stickers before the purchase. So no matter what number this is, we already had 3 in the beginning, and we'll account for that right over here. Plus 3 that we already had. So my party people, let's keep it simple. 2 times 10, that's going to be 20. And then we had the 3 from the beginning, leaving us with a total now of 23. And there we go. Pretty straightforward question. And I can definitely understand why the majority of us feel like, yeah, this is a pretty standard, straightforward question. So that was the first one. Notice, again, it was a pretty straightforward one. The problems can get harder or easier from here. We'll see. But before I continue, the unit that you will find this in arithmetic reasoning, let me write this in purple here. This is arithmetic reasoning unit number 1. This is the unit for generalized word problems. And this is where you'll see problems that have you just read the story and understand what is going on and putting the pieces together. No real formula. It's really just about understanding the context. Are we ready for question number 2? And let's get number 2 going here. So before we get started, let's do the same thing that we did before. Number 1, where do we feel the difficulty of this question is? Do you feel like this was a easy question, medium question, or difficult? How do we feel about this one? So definitely not the same sentiment as the first question, right? The first one we were saying, oh man, all easy. Now we're seeing a lot of mediums, a lot of so-sos, and a lot of difficults. I'm going to go ahead and give you the honest opinion here. This one is going to be, in my opinion, a level 2. Level 2 question. Not easy like a level 1, not crazy like a level 3. It's just something that if you know, you could score higher for sure. Now, the topic that this is from, I want to ask y'all, those of you who are in my program absolutely know, what category or what unit is this? What concept is this, my party people? Yeah, ratios and proportions. Absolutely. This is arithmetic reasoning, unit number 2, proportions. Again, for those of you in the program, that's exactly where you will find it. Also, again, when you try the game out, you can go ahead and isolate proportions to get more practice, just like this. So here we go. Let's get to it here. The question asks, what is the value of b? So before we confuse ourselves, before we start letting the anxiety take over, can we all agree that the problem says that there's some number that's represented by b, and we just want b? Can we be confident that that's what we're looking for? Good. And notice how I always start small. Always start with the goal, because it doesn't take a math wizard to be able to understand the goal of a problem. And so I'm really going to push that onto you, because I don't want us feeling like we can't even get started, when the truth is anybody here can identify the goal. We just want the value of b. Now let's understand what they give us here. So the information that they start off with is, if the ratio of a to b is 2 to 5, and a equals 14, what is b? Now let me write this out for you, and let me show you how to get proportions done the right way every single time. So here's what they say. They say that the ratio of a to b is 2 to 5. So if I'm writing this over here, a to b in terms of the ratio, everybody, which letter does the 2 belong to? Pop quiz. When it comes to ratios, and we're reading it A to B, yeah, that's right. The 2 has to be linked to A. Now, some of us may be asking, Coach, why, right? Why? Well, the reason is because the order matters. The order absolutely matters. If we say ratio of A first, B second, A first, B second. So 2 goes with the A, the 5 goes with the B. Now up next, notice how we're looking for B, but they give us A right here. Let me highlight that in green. A equals 14. Okay. Now what we're looking for here is B. That's what we're looking for. Everybody, does this look proper to you in terms of writing the ratio and then writing the comparison of the actual values? A is 2, B is 5. That's correct. And then we have A is actually 14. Now we want to know the actual value of B. Sweet. Now that we're here, now it's a proper time for me to reveal the main idea for proportions. Pop quiz for extra credit. Who knows the main idea for proportions? There's got to be at least 5 dozen of you who know it. What is the main idea behind proportions? And it's not just one word. There you go. Giancarlo came in first with it. Compare the same things in the same way. I'm going to come over here and I'm going to write that out. Again, main idea, the main idea for proportions, and you're going to hear me say this a million times over if you're in the program. It is compare the same things in the same way. Let me just finish writing this out here. Compare the same things in the same way. Surprised I wrote that well trying to write that fast. But there we are. Again, compare the same things in the same way. Here's the advantage that gives us here. Everybody, if we're comparing A to A, how do we go from 2 to 14? Multiplying by what number gets us from 2 to 14? Yeah, that's multiplying by 7. Now, my party people, notice what I just said. I just got done saying compare the same things in the same way. So if I'm comparing this line to this line, and the comparison is times 7, well, guess what? That means if we do the same comparison, top to bottom, it's the same thing, times 7. My party people, what's 5 times 7? Oh, look at that, 35, super quick, super straightforward. There's our correct answer, and we are done. And that's just one way to get it done, but nonetheless, the correct answer here would be B, 35. Another way to get this done, everybody, is by setting up a proportion, and what that would look like would be, hey, let's go ahead and do A divided by B and compare them to each other. So 2 divided by 5 equals 14 divided by whatever B is. And I'll just put X, or actually I'll just use the actual letter B to do that. And once you're here, what you would do is you would cross, multiply, and divide. There are other ways to do it with some mental math. Don't get me wrong, I love mental math, but to do it the fast way, we can absolutely just cross multiply and divide. 5 times 14, that's going to be 70. Then when we divide both sides by 2, that'll be B equals 35. So those are 2 ways to get it done. And the way that we got that times 7 was just utilizing the main idea with proportions that can oftentimes save you a ton of time. So here we saw that it was the comparison of times 7. So we did times 7 the other way, and it can get you to the answer very quickly. But if you prefer setting up the proportion and cross multiplying and dividing, this still works just as well. And I also saw another question in the chat box asking, hey coach, if we went ahead and set it up, not like we just did, but if we had something like, let me actually scroll up and see, what if you put B over 14? That would still absolutely work. You would just have to flip the other side with 2 and 5 being flipped. But yeah, and it depends on what you enjoy. Cross multiplication and division can be faster if you don't know these primary or shortcut methods. But I never encourage anybody to learn a shortcut until you know the main way very well. But either way, my party people, how do we feel about this first one? Do we feel like, hey, with some practice, proportions, we can definitely get this down? There's an avenue to getting this down. Right on. And I see that it's the majority that feels that way, but there is a group here that may feel like, hey, still a little confusing. I'm still a little lost. And that's why I'm making it a point to tell you the concept that we're working on. This is Arithmetic Reasoning Unit 2, Proportion Word Problems. And again, your main idea is compare the same things in the same way. So there it is, my party people. I got you there. Are we ready for the next question, the third one of this mixed review? Right on, right on. All right, so let's try this third one out here, everybody. So this question begins with saying today's Monday, and we want to know what day of the week will it be? How many days? Wait, hold on, what? 234 days from now. Okay, well, did anybody here go ahead and do the whole, let me just do it like this. Draw a little calendar and try to go ahead. Let me duplicate that right there. Let me just show you how long this might take. Let me do that and then grab all of this. Okay, almost done. I think we're good after this one. Okay, cool. And then we have, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then who here was like, okay, today is Monday, so let's start right here. And I'm going to go 234. Bet, why not? 1, 2, 3, 4, 5, 6. Did anybody try to do that? Or wish they could do that? Or try to do that at first? No, a lot of no's. Hey, look, my data on this type of question shows that at least 40% of y'all tried to do that. So some of y'all are fronting me right now, but it's okay. It's okay. I'm not going to point y'all out by name. So here's what we're going to understand here. It is, this is one of those questions, everybody, that if they said not 234, what if they said, hey, today's Monday, what day will it be? Let's go ahead and say 3 days from now. Everybody, if they said, what day of the week will it be 3 days from now, would this problem be easy? Right, absolutely. This question would be beyond easy. It would be, just an insult to your intelligence, right? Because if we start on Monday and we count 3 days, that's easy. 1, 2, 3, that's Thursday. That is Thursday. However, though, what do we do when we can't use our hands and fingers to count? That's why we need to know arithmetic reasoning. Reasoning beyond the simple methods. So let's understand how to get this answer, even though it is well beyond the amount of time that we have to solve this problem. Here's what we do. Everybody, how many days are there in a week? Okay, 7. Thank you. I almost forgot. I appreciate y'all. Now, let me go ahead and just point some things out. Let's start at Monday. Everybody, if I count 7 days, 1, 2, 3, 4, 5, 6, 7, did I land on the same day or is it a different day? Right, I landed on the same exact day. Every time I count 7, I'm going to land on the same day. What does that mean, everybody? Well, let me show you this little thing that I think everybody here knows about. Let me show you some long division. Watch this. Let me divide 7 days into 234. I want to see how many weeks are in 234 days. Watch this. 7 goes into 2. Well, it doesn't. But 7 goes into 23, everybody. How many times? Yeah, that's going to be 3 times. Okay, great. We do 3 times 7, which is 21. We subtract and we get 2 left over. Drop that 4 down. Everybody, how many times does 7 go into 24? Correct. That'll be 3 times again. I appreciate y'all. Right on. So that's another 3. So that makes 33. Subtract the 21 and we have 3 remaining. So what does this mean, everybody? What does this mean? This means that if we're talking about what day will it be 234 days from now, that is the same as saying 33 weeks and 3 extra days. Also shown as remaining days, the remainder, right? But watch this, everybody. Let me ask you again. If we go 1 week from Monday, 2 weeks from Monday, 33 weeks from Monday, what day of the week are we landing on? No matter what number of complete weeks we do, yes, correct, we still land on Monday, no matter what. So what really matters? The remainder. Because the 33 weeks, 33 times will land on that Monday right there. And then the 3 extra days, 1, 2, 3. Boom. We land on Thursday and we're done. And that's what this problem was about. In, pure math talk, this is called a modulus problem where you use the remainder to do work. But this is going to fall under general word problems. This is arithmetic reasoning, unit number 1. This is one of the word problem types that I love doing simply because it really takes, an interesting approach to say, I can't count that high in the 2.5 minutes that I have on the test. So is there a faster way? And right there, that is the faster way. Understanding how the remainder plays a part in 7 days in a week. So this is, again, arithmetic reasoning, unit number 1. General word problems is where you'll find more questions like this one. Right there. And boom. So with that said, are we having fun so far? Are we having fun? Even if we're getting some wrong here and there, are we feeling good about going through the solutions after we give ourselves a chance to try? Good. That's all. That's what it's always going to be about, everybody. Just again, one problem better, one problem at a time. That's what it's all about. So let's keep moving forward here. Even if you're still yearning for a little more explanation, don't worry, I got you. We're going to continue moving forward here because, again, it's a mixed review session. Not so much learning individual units, but seeing how well you perform under the pressure of being timed with these mixed topics. Next question coming right up. All right, so let's get into this next problem here, my party people. So before we get started, I want to make it very clear. This problem is part of the arithmetic reasoning unit number 3. All right, this is the third category, and this has to do with unit conversions. So my party people, who here automatically knew that this was part of unit conversions as you read through the problem? Good. If you feel like you're able to start recognizing topics as you complete the problem, that's a very good thing. That means that you've practiced enough to have that experience show up in new problems where you can say, oh, even though I don't know what's coming up, once I see it, I know what it is. So great job there if you did understand what topic we're doing. And if you did understand what topic we're doing and you still felt like you were a little confused, well, then pay attention to some of these checkpoints that I'll talk about here as we go through. So no matter what, everybody, the first thing we need to know is what we want to know. And what we want to know is what is the total cost of the purchase. So everybody, before we even know that this is unit conversions, before we realize that we forgot how to convert pounds to ounces, is it fair to say that we should still know what we're trying to find? The total cost of what we're buying. Thank you. Again, get into that mentality because the more you say, oh, it's unit conversions, I don't know unit conversions, you waste that opportunity to learn as much as you can from this problem. So treat every word problem like a brand new one. We want to know that total cost. Let me write that out right here. Total cost, nice and easy. And now let's go through the information and let's figure it out. So a vendor sells fresh blueberries, right on, at a price of 40 cents per ounce. Now, one of the tips that I have for dealing with word problems, especially if you have a little bit of anxiety towards those decimals, I would say, hey, look, a vendor sells fresh blueberries at a price per ounce, a certain number per ounce, whatever. If a customer purchases this many pounds and ounces of blueberries, what's the total cost? Now, why did I do that? Why did I brush over the numbers and really focus on the words? It's simply because, everybody, the numbers don't matter until you know what they mean. So let me write this down here. We have right there, it says the blueberries cost 40 cents per ounce. So let me just write this here. The cost is going to be blank dollars, so 40 cents is what I'm going to write, but you don't really care about that number. Just 40 cents per ounce. Let's read around this and let me zoom in here. Everybody, what do we need to do to get that total cost? If it says 40 cents per ounce, what do we need to multiply by to get that total cost? What do we need to multiply the 40 cents by? Don't give me a number. Do not give me a number. Tell me what idea I need to multiply by. Thank you, Jaslyn. Yes, because it says the dollar amount per ounce, we are going to multiply by the number of ounces. That's all you need to know. That's all you need. Well, I mean, obviously the conversion, you need that too, but we'll talk about that in a moment. But everybody, before I continue, does it make sense that if we want the total cost of the blueberries and it says 40 cents per ounce, we need to multiply this by whatever number of ounces we have? Does that part make sense before we continue from here? Awesome. Now, again, this is where I really want to emphasize, hey, if this is where you got confused, doing that conversion, this is really where you're going to want to pay attention, right? So here, just one more time, I got you, Johnson. Again, 40 cents per ounce. The per ounce means multiply by ounces to get the total cost. The cost per ounce times ounces gets you total cost. So here we go. How many ounces do we have? Well, it says the customer purchases 2 pounds and 6 ounces. Okay, there's a problem. We don't have it in just ounces. We see 6 ounces, absolutely. However, my party people, how many ounces are in a pound? Yeah, 16. So we are not just going to be multiplying by 6 ounces. If we do the 40 cents times 6 ounces, that'll give us something like $2.40. But notice how that answer is not there at all. And that's because that's not the answer. Because we need to convert the pounds to ounces first. 16 ounces in every pound means that I'm going to multiply this by 16 right here. That's 32 ounces. But my party people, are we just going to take this 32 or what are we forgetting? Yeah, we're forgetting those 6 ounces that are already there. So we're going to add the 6 ounces that are already there. And that's going to get us that final conversion of 38 ounces. This is 38 total ounces after conversion. So again, the conversion was necessary in the problem. So with that said, my party people, with that said, how are we feeling about the conversion? How are we feeling about the conversion so far? I gotcha. So if you're still feeling lost, this is where I would definitely point out that working with conversions, so turning pounds into ounces regularly, turning feet into inches, yards to feet, all of those conversions, especially time conversions as well, that's something that you're definitely going to need to know. And for the purposes of this question, I'll write this here. 1 pound equals 16 ounces. So that means 2 pounds, well, that was 32. 3 pounds would be 48, and etc. So the reason that I knew that is simply because, again, it's your responsibility to know these essential conversions, pounds to ounces, feet to inches. Those are all conversions that you must know. So we have ourselves, everybody, 38 total ounces. 32 ounces are from the 2 pounds, and the 6 ounces were already there. That makes 38 total ounces. Now, everybody, what operation did we say we need to perform once we knew the total number of ounces? That's correct. We wanted to multiply the price per ounce times the number of ounces. Now that we have the number of ounces, we can multiply by the price per ounce, and now we can get that total cost. So let's go ahead and do that right here on the right side. Let me move this down just a little bit, and let's give it a go. So 38 times 0.4. And I will do 0.40 just to, make sure everybody gets a chance to see it the normal way. So here's what we do, everybody. When we multiply by a decimal, the first thing we do is really just ignore the decimal. Ignore the decimal. Multiply like it's not even there, and then bring the number of decimal places back. So really quick, everybody, how many total decimals do we see? Well, for the 38, we see none. For the 40 here, that's going to be 1, 2. Let me just show that for you. 1, 2. 2 decimal places that we're bringing back. So let's go ahead and multiply like normal, nice and easy, and then bring 2 decimals back. 8 times 0, well, that's going to be 0. 3 times 0, oh, pretty easy, 0. Now up here, up next, we'll move over to the 4. So that means we'll put a blank 0 so we can start where the 4 is. 8 times 4, that's going to be 32. 2 right there, carry the 3. Then we have 3 times 4, that's going to be 12. 12, carry that 3, and that's going to be 15. So just like we said before, we're going to multiply like normal. We'll add everything up nice and easy. And so now we have 1,520. But what did we say? We said we're going to bring those decimals back. And so with that said, booyah, 1, 2, making the final price $15.20. And there we go. There's our correct final answer. It is answer choice. So one more time before we continue, everybody, the main issues that I can really foresee happening with this problem, it's going to be the ability to deal with unit conversions within the problem. Because everybody remember, if they just gave us straight up from the beginning, if they just said, yo, you got 38 ounces, not 2 pounds, 6 ounces. If they just said 38 ounces, everybody, would it be super easy to just say, oh, okay, cool. 40 cents times 38, get your answer and you're done. Right? It'd be pretty straightforward if they just gave you the number of ounces. So we need to be prepared for when they almost give us everything we need. And so part of one of those things is knowing how to convert between your common units. So with that said, everybody, hopefully we're having a good time so far. I really am. I'm really enjoying helping y'all out so far. Are we ready for the next one? Right on. Here we go. Let's go ahead and get going with this next one here. The first thing that I will lead off with, before I actually start solving the question, is where this is from. So my party people, this is distance, rate, and time. So for my program members, this will be found under Arithmetic Reasoning, unit number 5. This is going to be your distance equals rate times time unit. So with that said, my party people, what can cause some anxiety about this problem? Let's say in a perfect world, you knew the formula that you needed to use. You knew that it's distance equals rate times time. But, aside from the regular problems, what's different about this one that might give somebody a little bit of pause? Yeah, Ines, the decimals. The decimals can absolutely have somebody second guess themselves more than once in the same problem. Who here has that happened to? Who here has done a problem before that you swore you knew how to do, but because there was a decimal or 2 decimals in there, you were like, I'm not so sure anymore. Yeah, and that's what I've been saying this entire time in terms of having the responsibility of really knowing and fortifying those main concepts. Knowing how to calculate, knowing how to convert, that's an essential skill. And that's why I really tell you in the math basics, you've got to finish that first before heading into topics like this, because it'll have you second guessing yourself even when you know what to do if you don't know how to deal with numbers. So let's get to it, my party people. Let's solve this. Everybody, what are we trying to find here? The distance, rate, or time in this one. Yeah, in this problem, this one's very straightforward. It's saying, hey, find that distance. What distance does the car cover? Sounds good. So we're looking for that final distance. And here's how we know we're dealing with distance equals rate times time. When we read the information we're given, it says a car travels at a constant speed of 73.3 miles per hour for 3.2 hours. So, okay, how do I know? I don't see rate and I don't see time. Well, here, the rate is the same as a constant speed. Also, another way to determine rate is the word per. So miles per hour, basically telling you how quickly something's happening. Every hour, you cover 73.3 miles. That is a rate. It is telling you how quickly something is happening. So again, the main giveaways, the word speed, the word per, both of those are big clues. So the rate that we're using here, 73.3 miles per hour. And then the time period that we are given is 3.2 hours. So there we are. We know our formula here. Distance equals the rate times the time. And when we write that, hey, you can feel pretty good that if you got to the point of saying, yeah, I know how to get the distance, it's going to be 73.3 times 3.2. Even if you made a mistake after this point and you had the setup done properly, I'll still give you the kudos. You still deserve to feel good about this problem because you knew what needed to be done. You just need a little more practice with dealing with larger and different numbers. Is that fair to say for some of us here? Is that fair to say? Okay, sounds good. So let's go ahead and give it a shot here. 73.3 times 3.2. All right, there we go. And just like in the previous question, we'll ignore the decimals and then we'll bring it back at the end. So here we go. I'll go ahead and highlight this first one blue and then the second in red, just so we can see exactly how I'm working. So here, 3 times 2, that's 6. 3 times 2 again, and that'll be 6. 7 times 2, that'll be 14. All good. The 2 is done. Now we'll move over by putting a 0 so we can start the 3, right there. Next up, 3 times 3, that's going to be 9. 3 times 3, that'll be 9. And then 7 times 3, that'll be 21. Sweet. So now we're here. We can go ahead and add everything up. And we have 6. Then 6 plus 9 is 15. Let's carry the 1. Then we have 4 plus 9 is 13. Carry the 1. is 14. Then we have 1 plus 1 with an extra 1. That'll be 3. And then we have the 2 right there. So with that said, everybody, is that the answer, 2, 3, 4, 5, 6? Or are we forgetting one little thing that we are supposed to do? Correct. We're forgetting the decimals. So here's what we need to remember to do when we're multiplying by decimals. Multiply like normal. Great. And then we bring the decimals back. We have 1 up top, 1 on the bottom. So a total of 2 that we're bringing back. 1, 2, and there we go. Our answer is 234.56 miles. And there we go. There's the answer. And that correct answer here is C. And there we go. So who here feels like, again, you're right there. It's just one tiny thing that you forgot to do, one tiny thing that you just forgot at the moment. You know, who feels like that's really it? It's just tiny steps that we need to adjust to get to where we want to be. So that's what I'm talking about, everybody. That's why it's important to give your best on every single problem, because you never know how close you are to getting it right if you don't try your best. So with that, again, just to review the problem, it was a distance equals rate times time problem. We have the rate, we have the time, and so we just multiply those together to get the distance. From there, it's all about dealing with decimals and multiplication. And so if you forgot how to deal with decimals, again, I highly encourage you, Math Basics. Math Basics, it's unit number 3 for decimals, okay? Math Basics, unit number 3, if you go into the website, into the courses. So again, dealing with decimals, watch those videos there, because just going over this one specific example won't give you the practice you need to master it. So with that, my party people, are we ready to go to the next one? Oh, and also the reason we didn't need to convert the time is because this is already in hours. If they were to say 3 hours and 12 minutes, that's a problem. You would have needed to convert it into just hours, but this is already in just hours. So just wanted to make sure I addressed that. That was a very good question that we asked there, by the way. Sweet. All right, so let's go ahead and get into the next one here, my party people. We're doing a great job. Let's keep it up. So to begin this question, as always, we're going to read the question first. And it says, what is the sale price of the shoes? Okay, sounds good. Everybody, can we confirm real quick? Can we confirm that we are looking for the sale price of the shoes? Okay, sounds good. So this is the point of this particular problem. I left a note here in my notebook. I said, this is the point that I should say, if anybody has anger issues, please think about how grateful you are for me first before I reveal the potential easy mistakes that could be made on this problem. Again, just fair warning. So here we go. First thing, we want to know the sale price. So that's that. Okay, sounds good. Sale price is what we want. And then we see the information and it says a pair of shoes with a marked price of $120 is on sale with a 15% discount. What is that sale price? Okay, everybody. So real quick, let's go through the topic that we're doing here. This is going to be arithmetic reasoning, unit number 4. And this is going to fall under percentage word problems. So I'm just going to write percents here. Now, there is a formula that we will use for percentages. But more importantly, everybody, there is a main idea that we really have to adhere to. This is the key to success in this particular concept. Let me zoom on in. And here's the formula first. It's going to be the percent times the original equals the results. So just like that. Okay, so the percent times the original equals the result. And on top of that, my party people, there is the main idea. And that main idea is going to be the percent that you apply. The percent that you apply, let me just write it out fully. The percent you apply is the result you get. Is the result that you get. Now, how much sense does that really make on its face? Well, let me just help you out here. The percent that you see right here is the same exact idea, the same representation as the result that you get over here. So here's what I mean by this, everybody. Everybody, what percentage does that represent? That 15 that they gave us, what does that represent again? That 15 that they gave us? Yeah, that 15 that they gave us was a 15% discount. Let me show you what I mean by this. And this is how you can be confident every single time that you know you're going to get the right answer with a percent problem. I'm going to put in right here. So let me just keep this right there and kind of work down here. So let's say we have 15% times that 120, and we want to know what that's going to equal. Well, before I know what number that's going to equal, I know exactly what idea this is going to give me. Everybody, we said it already. That 15% represents the discount percent. So because the percent we're applying represents the discount, that means the result that we're going to get is going to represent the discount. Everybody, quick question. Are we looking for the discount? Is that what we're looking for? Is that the final answer? The final answer is going to be the discount amount? Oh, no, absolutely not. What did we say? We want the sale price. We want the price that we're going to pay. We don't want the amount that we're saving. We want the final price. So this is where I'm going to, again, hope that nobody here has anger issues, but this is where one of those common mistakes happens. Because most people, when they see the numbers and they think they know what to do, they immediately start hacking away, throwing the numbers together, and whatever they get, in this case, you would have gotten $18 for the discount. That would have gotten you to incorrectly say that the answer was 18. Because again, we're not looking for the discount amount. We're looking for the final price. So before I go back and calculate, just wanted to express that because so many of us are so close, but it's really going to be a matter of how much attention are we paying to the problem at hand. Does that make sense, everybody? Do we see how, again, rushing could get us the wrong answer here? Cool. Again, just trying to give you those little nuggets, those little lessons along the way. Fell for the trap? Hey, it's all good. I'm glad you fell for the trap here in practice. That way, hopefully on the test, we're all good. So let's go ahead and show ourselves the right way to do this. First and foremost, I'm going to show you first how to get that $18. So when let's say we're, going to calculate that discount anyway, what we're going to do at the end is we're going to subtract at the end. So I'm going to write then subtract right here. And then I'm going to come back and show you the much faster way to get this done. So here we go. Number one, first way, let's calculate that discount amount by doing 120 multiplied by 15%. As a reminder, a gentle reminder, always move that decimal place twice to the left before you multiply by a percent. So that's 0.15. So let's just do that right over here. And let's zoom on in and let's calculate. And let me actually do this with a little more room over here. So we have 0 multiplied by 5. That'll be 0. We have 2 multiplied by 5. That is 10. So right over there, boom, 10. Then we have 1 times 5, which is 5. Add the 1, and that's going to be 6. Now we'll go to the next line to deal with the 1 right here. And so we have 0 times 1, which is 0. 2 times 1, which is 2. And 1 times 1, which is 1. Add this all together, and we get 0, 0, 8, and 1. Everybody, how many decimal places do we bring back? Correct. That'll be 2 times that we're bringing back. Nice and easy. 1, 2, and that's going to be $18 discount. This is why it's important to understand how to get it done. So now we know what the discount amount is. And so all we need to do to get that final amount, everybody, let me know if you agree. To get the final amount, I got to take that beginning amount, subtract the discount, and I'll get the sale price. If I subtract the discount from the original amount, I'll get the sale price. Good. Now let's give it a shot here. So again, we have the original $120. We'll subtract the $18 discount, and that's going to give us $102. That is the final price. 102. We just have to subtract at the end, and we're good if we wanted to go that route. There is a much faster way to go about this, everybody. And I'm going to show you the other way right over here in the corner. So here's what you can do. You can subtract first. Here's what I mean, everybody. Quick question. What percentage represents the whole entire amount of anything? Yeah, 100%. So watch this. 100%, that's the original amount that we were supposed to pay. Everybody, the discount amount was 15%. Everybody, quick question. What do you do with a discount to get the final price? What do you do with a discount? Yeah, you subtract, exactly like we just did. So watch this. If I subtract, guess what? My final percentage that I'm actually going to be paying is 85%. This is super important because this is going to help us get the final answer right away. If you don't believe me, watch how cool this is. I can go ahead and say 85% times 120 equals whatever. This is my final percent that I'll be paying. So I know that I'm going to get the final amount as the result. So watch and learn. Here we go. Let's do $120 times that 85%. And just watch how this is going to get us the correct answer right away. Here we go. 0 times 5, that's 0. 2 times 5, that's 10. 1 times 5, that's 5. Carry the 1 is 6. Next, we'll move forward to the 8 right over here. And so we'll just put a 0 down, and here we go. 0 times 8, that's going to be 0. 2 times 8, that'll be 16. Carry the 1. 1 times 8 is 8. Carry the 1 is 9. And then from here, add it all together. 0, 0, 12, and then 10. And we bring 2 decimal places back, and that is $102 as the final amount, allowing us to get the final answer, again, right away from the very beginning, as opposed to having to remember that, oh, this is actually the discount amount, and I got to subtract it at the end. So this is the difference between memorizing and understanding. That is the difference, everybody. And I'm really hoping that these are exercises just reinforcing that necessary adjustment that we need to make. Yeah, absolutely. We can do both ways, but it really depends on what you're trying to get. Here is the sale price, so we make sure the numbers line up in a way that gets us the sale price. If we were just looking for the discount amount, this right here is enough. This is enough because you get the discount amount right away and you're done. So my party people, before we continue, do we see both paths to success here? Sweet. All right, so let's keep the fun going. No reason we should stop now. Let's keep it up. We still have 30 minutes left. Great job, everybody, so far. Next one's coming up right now. All right, so in this question here, my party people, what we're trying to do in this question is find the initial amount that this tutor earns, the initial amount before doing any actual tutoring. So let's go through and understand how we're going to get to this mysterious initial amount. So again, every time, everybody, just read the information to understand the story, and we'll take it from there. So a student earned money by tutoring. His earnings were determined by starting with an initial fixed amount and then adding $40 for every hour that he tutored. So after tutoring for 8 hours, earned a total of $400. So everybody, let me go ahead and let's lay the story out. Everybody, let's understand first, can we agree that the final total earnings that this student makes by tutoring, the final total earnings is $400? Can we agree with that in the beginning? Right on. Correct. Yes. So no matter what happens, we know that it's going to be equal to $400 in terms of the total earnings. So this is where storytelling is more important than the mathematics. Clearly, we're going to need to calculate later on, but if you can't put the story together, then it's going to be mighty difficult to actually do the math. So here we go. What do we know so far again? We know that his earnings are determined by a starting amount, some initial fixed amount. So I'm going to write that down right over here and highlight this in green. An initial fixed amount. So initial amount, it could be 10, could be 20, could be 30. It's one of these numbers. This is what that number represents, the answer here. So I don't know which one it is yet, but I know that after this tutor gets the initial amount, Then the tutor earns $40 per hour being tutored. My party people, can we agree that we see that this tutor here went ahead and again got $40 per hour of tutoring, and they tutored for 8 hours? Can we agree that we see with our eyes that we did 40 an hour for 8 hours? Awesome. We all like money. How do we get how much we earned from just the tutoring? Like, ignore the initial amount. How do we get this amount for the tutoring? What do we do with the 40 and the 8? That's correct. We are going to multiply. We're going to multiply. Because if it's 40 per hour and we do 8 hours, yeah, we got to multiply to get the total amount that we earn from just tutoring. So that'll be 40 per hour multiplied by 8 hours. And can anybody tell me what's 40 multiplied by 8? What's that going to be? Yeah, that's 320. So what we really know here, what we're putting together here is that the initial amount plus $320 is what gets our student tutor to $400. My party people, can we eyeball this logic and tell what the final answer actually is? Because it says some initial amount plus 320, it equals 400. Oh yeah, so then what does the answer have to be? What happens if we take away the 320? What is left over? What does that initial amount have to be? Yeah, it has to be 40. Or excuse me, it has to be 80. I don't know who said 40. That caught my eye first. Sorry about that. It is 80. Excuse that. So yeah, if we subtract the 320 from both sides right over here, that's going to be $80 as that initial payment for the tutor. And there we go. The correct answer here is B, $80. And there we go. Right on, right on. So the topic that this one is from, my party people, this one is going to be from Arithmetic Reasoning, unit number 6. This is going to be linear equations, word problems. So linear equations, word problems. Anybody here ever heard of y equals mx plus b? Yeah, so these are the types of word problems you're dealing with in unit number 6. Basically, y equals mx plus b word problems. There's a meaning behind every letter. And in that unit, in the lessons and in the guided practice, I teach you how to interpret the y, the m, the x, and the b, and how to know what to plug in for each. So that's going to be, again, Arithmetic Reasoning, unit number 6, for those of you in the program. All right, let's keep it going here. Let's not waste time. Let's keep going to the next problem up. Let's do a brand new topic here, and let's give this one a shot. So, my party people, what topic are we dealing with in this one? Yeah, we're dealing with probability here. We're dealing with probability. So, it says, what is the probability that the ball is red or green? Okay, my party people. So, the key word here of every single word in this problem, it's going to be probability. Probability is a very specific math word. And when it comes to calculating probability, everybody, is there a formula? Is there a formula that we need to know? Yeah, the answer here is going to be absolutely yes. There absolutely is a formula that we need to know here. And that formula is going to be this. So again, in the course, it's going to be Arithmetic Reasoning, unit number 12, statistics and probability. And the formula for calculating probability, my party people, is probability equals what you want over everything you have. It's again, what you want over what you have, or what you want divided by all possibilities. So I can erase what we have to make it more specific if you'd like to. But what you are dividing by is, again, all possibilities. All right? So let's understand this here, everybody. Let's understand what we want. Can you tell me in the chat box, what is it that we want in this problem? What do we want? Yeah, we want red or green. Exactly. Right here. We want red or green. So what we want, again, really boils down to red or green. Okay, cool. Now, with that said, everybody, how many reds do we have? Well, let's see. A bag contains 3 red balls, 5 blue balls, and 2 green balls. Okay. Everybody, how many red? Yeah, we've got 3 right there. So I'm going to mark that down, 3 red ones. How many green ones do we have? We have 2. Exactly. We have 2 green ones. So how many of these possible outcomes are we going to say are good for us? Well, again, it says red or green. That means either one of these is good. Since there are 3 red and 2 green, that means that there are 5 total ways to get what we want. We can pick any of the 3 reds or any of the 2 greens, but the logic is that there are 5 total outcomes that get us what we want. Everybody, before I continue to what we have and the possibilities, does that make sense? We got the 5 because we want red or green. 3 red, 2 green makes 5 total possibilities. That's the main part there. Again, understanding when you see the word or, what do? The word or means you can add those you can add those outcomes together. 3 red, 2 green. Well, either or means we have 5 total chances. Then from there, how do we calculate all the possibilities or what we have? Again, all possibilities. Well, everybody, we see that we have 3 red, we have 5 blue, and then we have 2 green. If we add all of that up together, everybody, what are all of the possible outcomes? What are all of the possible balls that I can select from at random? Yeah, that's going to be 10 because we have 3 plus 5 plus 2. Well, 3 plus 5 is 8, plus the 2 is 10. So our probability boils down to 5 over 10. The problem, my party people, is that, well, do I see 5 out of 10 listed here? I don't. And that's a little bit of a problem. But what's that one S word that we need to use here to get the answer? Yeah, we just need to simplify. If we simplify here, we're good to go. So let's go ahead and do that. Let me write this down. I'm going to write this down here in purple. So let's simplify from here. And everybody, we can simplify by 5 because 5 goes into both 5 and 10. So I can divide the numerator and denominator, or divide the top and the bottom, by the same number. So 5 divided by 5, that's going to give us 1. 10 divided by 5, that's going to give us 2. And there we go. The final answer here is 1/2. So you have a 1/2 chance, or a 50% chance, that the ball is red or green if you choose randomly. And there you go. The correct answer here is A. And there we go. So how do we feel about this one, everybody? Again, a little shift in the topic, but we want to know, how do you feel about your ability to look at different topics and still practice in the same way as if you were doing that topic this whole time, right? There's a big difference. There's a big difference between knowing what topic is coming up next and knowing what rules you're supposed to follow versus being given a random problem and you have to realize what the concept is, so you realize what rules you're supposed to follow so you can be confident about the steps you're going to take. It sounds crazy, right? It sounds like you have to prepare for so much, but that's why it's important to understand that studying for the ASVAB, it's about preparing early, studying often so you can build your confidence the right way instead of hoping and wishing and memorizing, the questions that you get. That's the difference, everybody. So let's go ahead and move forward here to the next one. We got time for one more. Let's crush it. All right. So here we go. All right, my party people. So before we get started on this one, just want to remind everybody about the game that is, again, being released tomorrow, the nice beta version for everybody to try out. So just as a reminder for those of us that really want to hone in on some of the topics that you learned today or really challenged or struggled with, well, remember, you can go ahead and pick arithmetic reasoning nice and easy. And then you can select the category that you want to work on. So for you, if that was percentage word problems, hey, nice and easy. You can click percentage word problems and you can practice basic percentages, percent increase or decrease, or financial applications like taxes and discounts and interest. And so you can select which one, or you can just keep it right there, hit begin game, and you'll be looking at some of the same types of questions that we've been doing here. You'll get the explanations after every question. You can see your streak get started, and then you can try another one and another one and another one in terms of that specific category. So give yourself the advantage of being prepared by, hey, once this is out tomorrow, boom, nice and easy, go after it, try out those challenge areas, and really verify if it was just a fluke or if you really do need to spend more time on that topic. So there it is. Just want to remind everybody about that. Now let's go ahead and crush this last problem. So number one, what's the question? It says, what is the perimeter of the rectangle? Okay, my party people. So the perimeter of a rectangle, let's remind ourselves, everybody. How do we find the perimeter of any shape? How do we find that? How do we get the perimeter of any shape? Not just a rectangle. We are going to go ahead and, add up all the sides. That's how we find the perimeter of any shape. Particularly in a rectangle, what we have is, well, we have a length and we have a width. So I'm going to go ahead and say that we have a length right over here and a width right there. And if we want to get the perimeter, we are going to just add up all the sides. So if there's a width that I'm writing on the right side, well, that's the left side also. Same thing with the length. If it's on the bottom, it's on the top. But what we really want to do is add 2 of those lengths and 2 of those widths. If we find the length and the width, we can just plug those numbers in and add them up nice and easy. But the real challenge here is, what the heck is the width and the length? Everybody, the first sentence gives one of them away. Which of them is given away in this first sentence? A rectangle has a width of 4 centimeters. Yeah, we know here that the width is 4. So let me just write this down. Highlighted 4 centimeters. And I'm going to replace the width here with 4 centimeters. Are we good with that before I move forward to trying to figure out what that length is going to be? Good. Because again, remember everybody, take it nice and slow. We're trying to find the perimeter of a rectangle. That means we have the lengths and widths. Got to add them all up. I know what the width is. It's 4 centimeters. Now let's see what the length is. Here's where I'm going to use purple. Let me just counter this over here. Use purple. Perfect. Now here's what it says. It says the length is, okay, so the length. Everybody, what does the word is mean in mathematics? The word is means equals, correct. So equals. Notice how I'm going to break this down word by word. Here we go. 2 centimeters more than. Everybody, if I'm writing down 2 centimeters more than something, what does the phrase more than something mean? Exactly, it means add. It means add. So it says 2 centimeters more than whatever this is. So I'm going to do whatever that is, more than that by 2 centimeters. Okay, now let's just figure out what this part is. 3 times the width. Oh, I know what that is. Everybody, 3 times means multiplied by 3. And what was the width again? What was the width again? If it's saying 3 times the width was, it was 4. It's right there. It's right there. So what we're going to do is we're going to do 3 times the width, which is 4. And we're going to do 2 more than that. 2 centimeters more than whatever that is. Now, we know what that's going to be because 3 times 4 is going to be 12. What's 2 centimeters more than 12, everybody? Oh yeah, that's going to be 14. So we had to take a tiny, small, minuscule little detour. But now that we've taken that detour, booyah, we are good because now we know that the length is going to be 14 centimeters right there and right there. And so what's up next? Well, now that we know the length and the width, we can finally calculate that perimeter. We can finally go ahead and add up all of these sides. So one way to do it is you can just go ahead and double this up here, double the 14 to get 28. And then you can double up as well on the 4s, and that'll give you 8 centimeters. So 28 plus 8, my party people, what's that going to be? Booyah, 36 total centimeters. You can do it other ways too. You can use your formulas. You can add 4 plus 14, which is going to be 18. Then plus 18 plus 4 is 22. 22 plus 14, 36. You can do it however you want. But long story short, to get the perimeter, just add up all those sides and we are good. Our final answer, the correct final answer for the last problem of the day is 36 centimeters. And there we go. So with that said, my party people, that brings us towards the end of the class. But the next class that we have coming up, if you're watching this live, it's going to be tomorrow. If you're watching this as a recording, hopefully the recording for the next class is up already. But in that next class, everybody, we are going to be reviewing tougher questions. Still some of those essential fundamental questions, but more of the medium to hard questions in tomorrow's class. And for those of us asking where to find this lesson, this is going to be area and perimeter. So arithmetic reasoning, unit number 8, area and perimeter word problems right there. But with that said, like I said, tomorrow's class is going to follow up on today with plenty more practice problems. And with that, I will see hopefully everybody here then.